Hello, my name is Chris. I am the student lead at the Data Science Education Program's Student Infrastructure team. I work on the team that develops Autograder, as some of you may have heard about, and I'm going to be talking today about autograding at UC Berkeley's data science curriculum. So this presentation will cover a few main topics. The first of which will be OKPI, which is the primary autograder used in Data 8. We will also be covering Autograder, which is the new open source autograding platform being developed at the SCP by my team, and some of the specific use cases of Otter and our hopes for its future. We'll also talk about some resources for writing autograder tests and the way that they should be structured, and then there are some resources at the end of this presentation with some helpful links. So to begin, OKPI is the biggest of UC Berkeley's autograding platforms. It is used in CS61A and Data 8. It was developed for CS61A, but does function as a Jupyter Notebook autograder as well. It is a server-based autograding solution with a local client component. And what that means is that when a student is working through a notebook, there is a Python package that gets installed that allows them to run publicly distributed tests that are packaged with the notebook, kind of as like a way of checking, am I on the right track? And it gives students the results of these tests to ensure that students' answers, while they may not be correct, are at least on the way to being correct. And these tests are delineated using keys in the test files that we'll go over in a minute. The server component is actually a web service hosted by CS61A that essentially collects backups of student submissions and the actual submissions themselves, and spawns Docker containers that will execute students' code and return a grade based on the execution of certain tests. And this kind of Docker containerized architecture is a very common theme that we'll see in the autograders today. So the OKPI server, which you can find at okpi.org, organizes classes and assignments and executes the student submissions. And the client package, as I said, allows students to run public tests in the notebooks, and since it also is what performs authentication, so students will run a cell at the top of their notebook, and that will provide them with a link to the OKPI website, which will have them auth with Google, and then send an OAuth token back to the notebook, which is then stored. And so that way, at the end of the notebook, when a student needs to submit, their token is sent along with their submission so that OKPI can assign the submission to the correct student. In Data 8, in classes that involve autograding Jupyter notebooks, OKPI is also commonly used in conjunction with Gradescope, which is a proprietary grading platform recently acquired by Turnitin that was developed here at UC Berkeley, and it is used for when a student submits, OKPI will generate a PDF of their submission and post that PDF to an assignment on Gradescope to facilitate the easy grading of questions that cannot be auto-graded. And this is kind of what OKPI looks like for students. We can see that there is a list of courses here that give them, the course name and the term and the institution. And this is essentially it's just like an LMS where students can go in, see their assignments, look at their submission, look at their grades, etc., etc. And this is the assignment breakdown view for Data 8 this past spring. And students can see here in this column their scores for each assignment, the submission status, and OKPI also supports group assignments. So that way it's very easy to collect submissions for groups and grade them all at once. The general workflow for an instructor using OKPI as a grading platform is to start off by creating a master notebook with JAssign. And the master notebook is essentially a Jupyter Notebook format that puts all of the required information into one file, which a tool called JAssign then will parse and generate the distribution versions of notebooks. So what this master notebook contains is all of the questions for the assignment, the solutions, and then cells that contain hidden and public tests. So that way, what all that JSLine has to do is it goes in and it reads and parses these cells. It takes the test cells, converts them to OK formatted test files that it then writes to different directories, and also will sanitize the solutions and replace them with ellipsis prompts or custom prompts as well. So a master notebook is a very easy way of abstracting away a lot of the assignment creation needs from instructors, and JSLine just allows you to put everything into one single file and then have everything that you then need to create your GitHub repo automatically generated for you. Once you've used JSLine and created your distribution repo, assignments are then distributed to students who will work on an already deployed Jupyter Hub instance with NB-Git puller links. And NB-Git puller is a Python package that works with Jupyter Hubs to, given a specific link, when a student clicks this link, they'll be redirected to a Jupyter Hub instance. And that instance will then proceed to clone a GitHub repo onto their profile so they can access the files in that repo. Or if that clone already exists, it will just pull any new updates without overwriting the student's previous work. Once the student has pulled the repo, they then complete the notebook and run a submit cell. That submit cell, as I noted earlier, sends their token and their notebook to the OKPI server, which will then execute their code in a Docker container and return the grade for the auto-graded questions. And that's in the server execute submission step. And then optionally, instructors can review and update grades for manually graded questions on the OKPI server, or as I noted earlier, there is the OKPI grade scope integration that is possible where manually graded questions are farmed out to Gradescope as the LMS. So in this example from data 8, we can see that at the top of the notebook there is this initialize OK cell. And what this does is it creates the instance of OK from the client package that will allow students to run those checks. And the second part of this is here in this import cell, this OK.auth call. And what this does is it performs the authentication of students that allows them to have their API tokens stored in the notebook. So this will tell students, please visit this URL, log in and copy your API key and paste it back in this notebook. And that is what allows students to submit directly from inside the notebook. Then, when a student has finished a question, after the question, they will see a cell that looks like this that calls OK.grade. And what this does is it runs the OK, the publicly distributed test, Q11, and returns to students the output of the test, whether they passed or failed. And if they failed, it also gives them a helpful hint of like, here is the code that we ran, and this is the output that we expected, but this is the output that we got. So that allows students to, like as I noted earlier, to make sure that they're on the right track. And it's at the instructor's discretion what tests are distributed publicly and which ones are distributed privately. So a test file is a very simple file. It is just a Python file, as you can see here. And these Python files have a structure that's very simple, where a single global variable called test is defined. All lowercase, it is case sensitive. And that is set to a dictionary that defines the configurations for the test. So it has a name, it has a point value, it has a list of suites. And a suite is just kind of a set of tests. Suites are then divided into cases, and a case is like one single functional unit of a test that has a code string. This string is a doctest formatted test. So that way what happens is doctest will parse this input here and then will execute this and say, okay, this is the output that I expect to receive. Each test case has a hidden and locked parameter. Hidden is used for hidden tests, and locked is used for unlocking tests, but those are not really use cases very commonly found in Data 8. And tests also have, test suites also have scored, setup, teardown, and type parameters. And in Data 8, you will only see tests of type doc test, which is just indicating that these cases are just doc test formatted strings, so that it tells the autograder to execute this, and this is the output that I expect to receive back. So this is the anatomy of an OK formatted test file. It's a very simple structure. All of these are then put into files, .py files, that are then put into a tests subdirectory of the assignment directory. So if I were to go back up here to homework 01, you would see the .ipynb file and the homework01.ok file. And also note that these have an init.py file, so that tests can be imported as a Python package. If you're using jassign, all of this structuring of tests is abstracted away from you, and you will just write tests as a cell of a Jupyter notebook. And then jassign will parse those and write these files and in this format for you nicely and neatly. But this was the general structure of the assignment repo. So moving on now, Autograder is a new open source autograding solution being developed currently by my team at the Data Science Education program. And it is a local modular autograding solution optimized for customizability. Its original use case was for grading entirely locally in parallel Docker containers on an instructor's machine. This is a use case that's designed for smaller classes of 30 to 50 students, where the instructor can collect assignments on their own platform or in whatever way they see fit, and then just run Otter on their laptop or their machine to just execute the student's code and assign a grade. So it's a completely local, containerized autograding solution. Otter is actually on the verge of its version 1 release. We are currently in beta testing on one of the larger data science courses on campus, Data 100. And this version 1 release features an assignment development tool called AutoAssign. That is essentially a fork of OKPI's JAssign. It is compatible with many third-party LMSs, including Canvas and Gradescope, and it includes a local client for students to run checks and expert submissions, which is a two-part system of the thing comparable to what we just saw with OKPI of the notebook class and its ability to run public tests in notebooks, and also a command line utility that's very similar to OKPI's command line use, which is used more commonly in CS61A. So Autograder, as I noted earlier, is compatible with many LMSs, Gradescope being one of them. And this compatibility is the root of Otter's most common use case, wherein instructors will create assignments with AutoAssign, generate a configuration zip file from their tests and assignment resources using a tool called Autogenerate, which will then be uploaded to Gradescope to create a container image that will then be used to auto-grade student submissions. So this zip file you get from Autogenerate defines a set of configurations and a method of running tests for each student submission. All of that is abstracted away by Autograder, so that all an instructor needs to provide are their tests and any data files or requirements needed to execute the student's code. A student will then upload a submission, which is a zip file generated in the notebook using the notebook.export function. When a student uploads that file, Gradescope will spawn a container that grades the submission and has some helpful output, including the breakdown of the grade for the instructors to see, the output of public and private tests, and those will be hidden according to the visibility of the test. And it also can optionally upload PDFs of notebooks to another separate Gradescope assignment for manually grading questions, similar to the OKPI's ability to upload PDFs to Gradescope, but this is a from Gradescope to Gradescope transition. And as I noted, this is the most common workflow for Otter. So in this workflow, assignments are created as programming assignments, which we can see here. And then optionally, PDF assignments can be created for manually grading questions. So what happens is once a student has submitted and the autograder is finished running, the instructor will see this autograder output box, which is just the standard out of the grading process. And so any print statements executed in the notebook will be printed out here. And then there's this little paragraph that describes what the output is that you're seeing, and then a printed data frame that summarizes the student's score test by test. And so we can see here, if a student passes both tests, there is just a single line that displays a 1 out of 1, or 3 out of 3, or whatever the point value of the test is, and the visibility of visible. If a student fails a public test, then it would just be a 0 out of whatever, and the visibility of visible. But if a student passes a public test, but fails a hidden test, then there are two rows in this data frame. One that shows that there is a visible test of worth 0 points that was passed, and another of a hidden test that's worth the actual number of points but was failed with a 0, and that visibility is hidden. And this structure corresponds to these boxes that you can't quite see here below, and that there will be two boxes for Q32, one of which shows the failed output of the hidden test. And the visibility of this standard out and of the output of the hidden test is all customizable in Otter using flags in Autogenerate and other behaviors in AutoAssign. So our goal for Otter is pretty wide-ranging. One of our more short-term goals is to update our Canvas LTI to allow instructors to auto-upload grades to Canvas. In the common use case of Otter plus GradeScope, this Canvas LTI is abstracted away by GradeScope, which automatically features already Canvas LTI, but this LTI would be for our Otter grade functionality, which is the original functionality of grading entirely on an instructor's machine. We are also looking into some Microsoft collaboration, making Otter compatible with Codespaces, which is their new VS Online product, and completing a GitHub Classroom LTI. We're also wanting to get more involved in Project Jupyter, for example, with an Otter Submit extension for notebooks or Jupyter Lab that allows students to have the submission process be even easier, and continuing front-end support for Otter Service that makes an Otter Service instance more like a class-by-class deployment of something like the OKPI server that would have front-end support so that students and instructors could go in and manually grade questions and see grades. So with that, we move on to the last topic of writing autograder tests. And in data science classes at Berkeley, we use the OK test format, which was originally developed for OKPI, and it is that same test format that I went over earlier. But test files are pretty simple, and they contain configurations and expected input-output for tests. Tests are formatted as Python doc tests, so if you just read over the Python doc test module that defines the way that it works, essentially it's just if you were to type code into a Python interpreter in your terminal, how would that look? That is the Python doc test format. And then our recommendation for the easiest way of doing this is to use a master notebook tool like JAssign or AutoAssign that will generate these test files automatically, and they abstract away the need to figure out the doc test format, to figure out what configurations exactly you need. All of these are done using sensible defaults and code that was written just to make life easier for instructors. So our recommendation, as I noted, is to use JAssign or AutoAssign or some other master notebook tool to generate these test files automatically. And we are also over at DCP in the process of writing this guide here, autogradertest.readdocs.io. That is a guide to autograder test best practices and ways of thinking about the best ways to write tests to make sure that they handle edge cases and that they break for as few students as possible. We also have an OK test generator. If you choose not to use something like JAssign or AutoAssign, This website, under a subdomain of my website, will allow you to create those .py files with the right structure just using some configurations that you provide in this nice HTML rendered format. So you just give the test name, the number of points, you give the input code and the output expected, and just click generate, and it'll create the .py file that you can download and put it into your assignments repo quite easily. All right. And last but not least, here are some resources. So here we have the OKPI website, the server, and OKPI's documentation, the repo for JSign, Otter's the beta release documentation for Otter, the test generator I just mentioned, and the test etiquette documentation that I just referenced a minute ago. And with that, I'm coming to the end of my presentation. Thank you so much for listening. I hope this was helpful, and have fun with the rest of the workshop.